In Chapter 10, exercises 1 and 2, we saw that acids and bases are defined by their ability to either give an H plus away, in the case of an acid, or accept an H plus, in the case of a base. In exercises 3 and 4, they're asking you to draw what is called the conjugate base for a few acids. And so the new term in this that we have to get to grips with in order to answer this question is the word conjugate. And that has a very specific meaning in chemistry. A conjugate is a molecule that differs from another molecule only by the difference of one H plus. Now, let's illustrate this by thinking of the conjugates of H2O, water. You could either have one more H plus, so one more H plus, or you could have one less H plus. In both of those cases, you'll get new molecules that differ from H2O by just one H plus. If you have one more H plus, that's called the conjugate acid. And if you have one less H plus, that's called the conjugate base. Okay, so starting with water. How many H's does water have? We're going to add two things. We're going to add an H and we're going to add a plus charge. How many H's does water have? It has 2. So if we add an H, how many will it have now? 3. We're not just adding an H though, we're also adding a plus charge. So let's look at the charge at the top right of water. What's the charge on that? Nothing is written at the top right, so it's 0. 0, if we add plus 1, we'll get plus 1. And so H3O plus is the conjugate acid of H2O. How about the conjugate base? Okay, let's go back to H2O. We want a molecule that has one less H plus, and that's going to be the only difference. So how many H's does H2O have to start with? 2. If we have one less, that means we would only have 1. Everything else stays the same. We're not just subtracting an H though, we're also subtracting a plus. So what charge does H2O start with? Nothing is written in the top right, so it starts with a 0 charge. We're subtracting a plus 1 charge. 0 minus 1 is a negative 1. And so the conjugate base for H2O will be HO minus. You could also write that OH minus. So a conjugate is something that has a difference of just 1 H If you have one more, then you're a conjugate acid. If you have one less, then you're a conjugate base. Okay. Now, each of these questions is going to be asking you for the conjugate base, but on an exam, you should be prepared to draw either the conjugate acid or the conjugate base. So although they're only asking for the conjugate base in these questions, I'm going to go through how to solve for both of them, since you could be asked about both of them on an exam. So this is going to be our framework. We'll do that, use that thought process for each of these molecules. Okay, so the first one, we want to draw the conjugate base. I'm going to draw both the conjugate acid and the conjugate base for each of these. So let's start with HF. To draw the conjugate acid, you would want to add an H and add a plus. So HF starts with only one H. If you add an H, it would then have 2. The rest of the molecule stays the same. And the charge is the second thing that we have to add. So HF, look at the top right, nothing is written there, starts with a 0 charge. Oops. If we add a plus 1, then 0 plus 1, you'd have a plus charge. And H2F plus is the conjugate acid of HF. How about the conjugate base? In the case of the conjugate base, we want to subtract an H and subtract plus 1, subtract 1 from the charge. HF starts with 1H. Nothing is written at the bottom right of the H, so it's an implied 1. If you lose the H, then there are 0 H's left. You only have the F. So we subtracted an H, now let's subtract the plus sign. HF starts with a 0 charge because nothing is written in the top right. If you subtract 1 from that, 0 minus 1 will give you a negative 1 charge. And F minus would be the conjugate base of HF. Alright, let's try water. And actually, this is the one that we did at the very beginning as an illustration. So we saw that if you have H2O, to get the conjugate acid, you add an H and you add a plus sign. H2O starts with 2 H's. If you add 1, then you'll have 3. So it'll be H3O. We're not just adding an H, we're also adding a plus sign. It starts with a 0 charge because nothing is written in the top right. If you add plus 1 to that, then you end up with 0 plus 1 is plus 1. So that H3O plus is the conjugate acid of H2O. Okay, let's think about the conjugate base. We're going to take H2O and subtract an H and a plus 1 from the charge. H2O starts with 2 H's. We're going to subtract one of them. So now it's only going to have 1 H left. We're not just subtracting an H, we're also subtracting a plus 1 from the charge. H2O has a 0 charge because nothing is written in the top right. If you subtract plus 1 from that, 0 minus 1 is going to be negative 1. And HO minus, you could also write it OH minus, would be the conjugate base for water. Okay, how about for this third one? H2CO3, it's called carbonic acid. It's formed whenever the water in rain passes through carbon dioxide in the air. And it's one of the reasons why the more carbon dioxide there is in the air, the more acidic the rain is. So let's see if we can write the conjugate acid and the conjugate base for this. So first the conjugate acid. This molecule starts with 2 H's. We want to add 1. 2 plus 1 will give us 3 H's. The rest of the molecule stays the same. We're not just adding an H, we're also adding a plus sign. At the top right of carbonic acid, there's no charge, nothing is written there. If we take 0 plus 1, we end up with a plus sign. So H3CO3 plus would be the conjugate acid of H2CO3. How about the conjugate base? In the case of the conjugate base, we want to subtract 1 H and 1 plus sign. H2CO3 starts with 2 H's. If you subtract 1, only 1 will be left. The rest of the molecule stays the same. Then we have to think about the charge. H2CO3 starts with a 0 charge. Subtract plus 1 from it. 0 minus 1 is negative 1. So the conjugate base for H2CO3 will be HCO3 minus. Okay, let's think about HSO4 minus. So that's going to be our new molecule. And we want to draw both the conjugate acid and the conjugate base. Even though this question is explicitly only asking for the conjugate base, either of those could be asked on an exam, so I want to show you how to do both. First, let's draw the conjugate acid. HSO4 minus only has 1 H. If you add 1 more H to it, then you'll have 2. The rest of the molecule stays the same. Now let's think about the charge. There's a negative 1 written in the top right of this molecule, so you start with a negative charge. If you add plus 1 to that, negative 1 plus 1 gives you 0. So there isn't going to be any charge at the top right of this molecule, and you just leave it blank. So H2SO4 would be the conjugate acid of HSO4 minus. Alright, let's try to find the conjugate base. We're going to take this molecule and subtract an H and a plus 1 from the charge. HSO4 has just 1 H. If you take 1 away, then it will have 0 H's left. So you'd only be left with SO4, because the rest of the molecule stays the same. But we're not just subtracting an H, we're also subtracting a +1 from the charge. This molecule already has a -1 written in the top right. Now, no number is written here, but when you don't have a number written for the charge, it's an implied 1. So you start with -1. We're subtracting a +1. So -1 minus 1, that'll be -2. And the charge at the top right of this new conjugate base will be -2. So the conjugate base of HSO4 minus will be SO4 2 minus. Okay, so let's follow that same procedure for these other molecules. So first I'll just paste that skeleton into here, that conceptual framework that we worked out. Okay, so first HSO3 minus. We want to find the conjugate acid and the conjugate base. To find the conjugate acid, add an H and add +1 to the charge. HSO3 minus has just one H in it because the H doesn't have anything written at the bottom right. If you add another one, you'll have H2SO3. So much for the H's. Now let's think about the charge. At the top right of this molecule, there's a -1. If a number is ever not written with a charge, then it's an implied 1. So -1. If we add +1 to that, -1 plus 1 gives you a total of 0, and we wouldn't write anything in the top right of this new molecule. The overall charge would be 0, and H2SO3 is the conjugate acid of HSO3 1 minus. Okay, let's try to find the conjugate base. So we take the molecule they give us, HSO3 1 minus. We want to subtract an H and subtract a +1 from the charge. HSO3 1 minus has only one H. Take the H away, and you have none left. So you'd be left with SO3. So much for the H. Now let's subtract +1 from the charge. The charge starts as -1. If we have 1 less, so we subtract +1 from the charge, then the overall charge will be -2. And that's what you'd write in the top right. So the conjugate base for HSO3 1 minus is SO3 2 minus. Okay. Let's try to see if we can find the conjugate acid and conjugate base for this new molecule, H3O+. So we're going to write that here, H3O+. First, to draw the conjugate acid, we want to add an H and add a +1 to the charge. H3O plus has 3 H's. If we add an H, then we would have 4, H4O. Not only do we want to add an H, but we want to add a +1 to the charge. H3O plus starts with a +1 charge. If we add 1, then we'd have a total of 2. So you'd have +2 in the top right. And H4O2 plus would be the conjugate acid of H3O plus. Let's see if we can find the conjugate base. To find the conjugate base, we subtract an H and subtract +1 from the charge. H3O plus starts with 3 H's. If you subtract 1, then you're left with 2. So much for the H's. How about the charge? H3O plus starts with a +1 charge. And no number is written, but that means it's an implied 1. If we subtract a +1 charge, then the overall charge will be 0, and we won't have to write anything in the top right of that molecule. So the conjugate base for H3O plus is H2O. Okay, let's try with this next molecule, HPO4 2 minus. Alright, so first let's try to find the conjugate acid. We're going to do that by adding an H and adding a plus to the charge. HPO4 2 minus starts with just one H, because no number is written at the bottom right of that. If you add 1 to that, then you'd have 2. The rest of the molecule stays the same. So H2PO4. Now let's think about the charge. The charge starts as a -2. If we add +1 to that, then you would end up with -1. And so that's what we'll write in the top right of the molecule. So we added an H to the molecule, and we added a +1 to the charge. So the conjugate acid of HPO4 2- is H2PO4 1-. Now let's see if we can draw the conjugate base. So the first thing we'd want to do is remove an H, and then we're going to remove a +1 from the charge. HPO4 has only one H in it, because there's nothing written at the bottom right of the H, so it's an implied 1. If we take one H away, it only had one to begin with, so now no H's will be there, and we'll just be left with PO4. So much for the H's. Now let's think about the plus sign. HPO4 2- starts with a -2 charge. If we subtract a +1 charge, then you'll be left with -3. And so that's the charge that'll be written at the top right of this molecule. So the conjugate base of HPO4 2- is PO4 3-, phosphate, the compound that's in ATP, adenosine triphosphate, and that also links the different bases together in DNA. Okay, last but not least, HNO2-. Let's see if we can draw the conjugate acid and conjugate base of that. To draw the conjugate acid, you would want to add an H and add a plus. HNO2 has one H in it. If you add an H, then you would have 2. The rest of the molecule stays the same. Then, we want to add a +1 to the charge. Nothing is written at the top right, and so the charge at the beginning is 0. If we have 0 and add a +1, then the overall charge is +1. You'd write that in the top right, so that the conjugate acid of this molecule would be H2NO2 +1. Let's see if we can draw the conjugate base. To get the conjugate base, we subtract an H and subtract +1 from the charge. HNO2 only has one H, because nothing is written at the bottom right of that H, so it's an implied 1. If we take one H away, well, it only had one to begin with, so no H's will be left. You only have NO2. So much for the H. How about for the plus charge? The charge starts as 0, because nothing is written in the top right of the molecule, and we're subtracting a +1 charge. So 0 minus +1 is -1. That's what you'd write in the top right. And the conjugate base for HNO2 would be NO2 1-. And so that's how you can use the specific term conjugate, which means a molecule that has a difference of just one H+, to predict the conjugate acid, a molecule that has one more H+, and the conjugate base, a molecule that has one less H+, for a given acid or base.